we are going to talk about the relational algebra. This is the last part of this chapter. The theoretical way of manipulating a relational database, we are using it in terms of a relational algebra. It can include operations that can act on existing tables to produce new tables. Each command ends with a given clause, followed by the table name. Clause request the result of the command to be placed in a temporary table with a specified name. Let's look at some of these commands. First, we are going to look at the select. It takes the horizontal subset of a table, retrieves certain rows from an existing table based on criteria, and save them into a new table. It can include the word where, followed by a condition. We will look at these select statements more in detail in Chapter 3, where we are doing the SQL statements. The example could be select customer where, that's the condition, customer num equals to 586, and then we given the answer. Next one would be the project. It takes a vertical subset of a table. It causes only certain columns to be included in the new table. It includes the word over, followed by a list of columns to be included. Again, we use this in the SQL command. Projects, customer, over, and then we have the customer number is another field, the customer name is another field, and then the given answer. Join, which we did it in QBE, we can also use a join statement. Allows extraction of data from more than one table, which we saw in the QBE. Two tables being joined together. The column would be called join column. It's a common column on which two tables are being joined together. For example, maybe there is a customer number in both of those tables. Row in the new table will be the concatenation or combination of rows that each original table will have. We will have natural join. We join the records from each original table that's common to both tables, or we might have an outer join, which joins the records from each original table, including records which are not common to both tables. We will look at these more in detail when we are going to actually use the SQL statement with the join. So we will have normal set of operations, which will be union, intersection, and difference. Union of tables of A and B, for example, the table containing all rows that are in either table A or table B, or maybe in both table A and table B. For intersect, it's the same as union, we just use the word intersect table. Table containing all rows that are common in both table A and B. And difference, we just use the word difference. It refers to as A minus B. Set of all rows that are in table A, but they are not in table B. Product, mathematically called the Cartesian product. Table obtained by concatenating every row in the first table with every row in the second table. So you can just do the product of the orders table and items table, as you can see in this example. Division can be best illustrated by considering division of a table with two columns by a table with a single column. So in here, we have basically we are the resulting of dividing the order line by item would be this one. So you are dividing the order line by item. Okay, let's look at the summary of this chapter. The relation, as we said, two-dimensional table in which the entries are single valued. Each field has the distinct name. All values in fields are values of the same attribute. Orders of fields is not important. Each row must be distinct, and the orders of row is also not important. The relational database is collection of relations. We said a table should have a primary key, which is a field that uniquely identifies a given rows within that table, such as social security number. We talked about QBE, or query by example, which is a visual tool for manipulating the relational database. We also talked about the criteria. We talked about the AND and OR. To indicate the AND criteria in an access, we place both criteria in the same criteria row of the design grid. To indicate the OR criteria, however, we are placing the criteria on separate criteria rows on the design grid of the QBE. To create a computed field in access, we enter the expression in the desired column of the design grid. To include the functions to perform calculation in access, we include the appropriate functions in the total rows. To sort the query in access, we select either ascending or this descending order in the select row, in the sort row of the field. To join the table in access, we place field list of both tables in the upper pane of the query windows, and then we bring more tables. We can also make the same change to all the records that satisfy the certain criteria by using the update query. We can also delete all the queries that satisfy certain criteria by using a delete query. We can also make a new table by actually saving the result of the query that we have into a new table. We talked about relational algebra, which is a theoretical method of manipulating the relational database. Some of the commands that we discussed, which we will discuss more in chapter 3, will be select commands, which selects only certain rows, project command, which selects only certain columns, join, which combines data from 2 or more different tables based on their common column. We talked about normal setup operations, which is join, intersection, and difference. We also talked about products of the two tables, which can result from concatenating every rows in the first with every rows in the second table. Division process, we also talked about it, which can divide one table by another table. I hope you have enjoyed this week's module, and I will talk to you next week. Take care. Bye-bye.